Alright, starting video number 2 for chapter 3. Covers accuracy versus precision. So the definitions here are listed. Accuracy is how close a measurement comes to the actual or true value. So you've got to have some kind of a true value, like knowing that the boiling point of water is 100 degrees. You could do an experiment, you may not get exactly 100. So it would mean whether you were accurate or not accurate, depending upon how close you got to that true value. So an example would be, say that I have a series of measurements here. I have 2.1, I have 2.5, and I have 2.3. That's one person's results. So say I have another person go back and measure something, maybe the distance of something, and they get 1.7 one time, they get 2.8, and they get 2.7. And I tell them that the true value, which I'm just writing as TV, the true value for this measurement is actually 2.2. What I want to know is which person, the red group or the blue group, would actually be more accurate in their measurement. So the answer would be this person right here. That person would be more accurate because as each one of their measurements was closer to that true value of 2.2 than the other group. So that's what accuracy is. Moving on, looking at precision. Precision is how close a series of measurements are to one another. So it's where they're located. So if you're looking at the picture of the bullseye, when you're talking about accuracy, to be accurate, you hit the bullseye. Every time if you hit the bullseye, then you're accurate. But precise would be maybe if the person hit a series of measurements, and I'm looking at the bullseye up on the right side. Say they hit a series of measurements right there, all in that kind of the top corner there. They're not accurate, but they would be precise because they were hitting the same spot every time. So my example for this one would be if I have a series of measurements again. Say I have 20, 25, and 18. And then I have another group take a measurement of something and say they get 20, 21, and 20. So looking at those two groups, with the red group or the blue group, which one would be more precise in their measurements? So the answer here would be the 20, 21, and 20. Now this one doesn't have a true value that I'm comparing it to. I'm just comparing how close those measurements are to one another. So 20, 25, and 18, those are really spread out. But the fact that one person got 20 and 20 on another time, and then with the 21, that makes it more precise. So that's the difference between what accuracy and precision is. Alright, how to determine error in your measurement. So you're trying to figure out the difference between what an accepted value is, which accepted is the same thing as true value, what I talked about before, and the experimental value. That would be if I said, okay, I want you to go back in the lab, I want you to boil some water. Well, we know that the accepted value for the boiling point of water in Celsius, not Fahrenheit, is 100 degrees. Well, say you go back there and you do an experiment and you actually get it to boil at 99.1 instead of 100. You're pretty close, but you still have some error in your measurement. Now to find that error, what you would do is you would take your experimental value, which in my case or your case would be 99.1. I would subtract that by the accepted value. So this would end up being a negative number, and that's fine, but you're just trying to find the difference. So it would be a 0.9 degrees Celsius difference. That would be my error. So that's a pretty good error in that case. If you move on, you can use that error to actually find out what your percent error is. So again, percent errors can be positive or negative. So what I would do in that case is take my error that I had before, which was 0.9. I would divide it by the accepted value. Remember the boiling point of water was 100. And then I'm going to take this times 100, not times 100%. Ignore that. And then that just ends up being 0.9% is my percent error in that case. So just because a measuring device works doesn't mean that it's accurate. So you could have had a thermometer that maybe something was wrong with it, or a measuring device if you try to measure the mass of something maybe it's not accurate. So just because you get a result doesn't mean that it's completely accurate, but there's nothing wrong with that. So that's just kind of a quick overview of what accuracy, precision, and then percent error is. This is the end of this video. Thanks.